Okay, let me solve problems about the vertical motion or the motion of a freely falling body. Number 1. A ball is thrown vertically downward with a speed of 18.0 meters per second from the top of a building 25.0 meters high. A resistance can be neglected. The questions are: first, what is the velocity of the ball just before it strikes the ground? Next, how long will it take the ball to reach the ground? Okay, let us first write what are given. We are given an initial velocity of negative 18.0 meters per second. Negative because the direction of the motion of the ball is downward. And the value of y, the displacement, is also given. It is negative 25.0 meters. So negative because it is moving downward below the reference point or below the origin. How do we calculate the velocity of the ball just before it strikes the ground? So given initial velocity and given the value of y. Okay, so what we need is v squared, the final velocity squared, equals v initial squared minus twice of g times the value of y. We have v squared equals negative 18 squared, then minus twice of 9.8 times negative 25.0 meters for the value of y. And then we have now 18 squared or negative 18 squared is 324 m squared per second squared plus the product of the three of them is 490 meters squared per second squared. Then add, we have v squared equals 814 meters squared per second squared. Then get the square root, so we have now plus and minus square root of this amount. We need to select the negative sign. So v is equal to negative 28.5 meters per second. So again, negative because the direction of motion of the ball is downward. Then how long will it take the ball to reach the ground? At what time? So what equation must be used to calculate the value of the time? So we have the formula V equals V initial minus G times time. Then we are given V, we have negative 28.5 meter per second. And then V initial is also negative 18.0 meter per second, then minus 9.8 meter per second squared times time t. Then transpose this term here, we have 9.8 m squared times time. Then transpose this number to the right side. So what we have now is 9.8 meter per second squared times time. Then we have 28.5 minus 18, we have 10.5. Then divide, we have 10.5 over 9.8 is 1.07 seconds. Number 2. A ball is moving vertically upward from the ground. Its speed, when it is at a height of 34.0 meters, is 18.0 meters per second. So the first question is, what is the ball's initial velocity? Next is, what is the maximum height reached by the ball? Okay, let us first write what are given. So we are given the height from the starting point to point 1, which is equal to 34.0 meters. And the velocity at point 1 is 18.0 meters per second. Okay, now let's look at this diagram of a ball that is moving upward. So from the starting point to point 1. So this height is 34.0 meters, y01. And at point 1, so v1 is 18.0 meters per second. So given v1 and this height, what equation must be used to calculate the initial velocity of the ball? Okay, so we have the formula v1 squared equals vo squared minus 2g times the height y01. So v1 is given, we have 18 squared plus the unknown v sub 0 squared minus twice of 9.8 times 34 meters. So we can find vo squared. We have 18 squared equals 224 meters squared per second squared. So plus the product of these 3, 2, 9.8, and 34 is 666.4 meters squared per second squared. Then add the two of them, so we have VO squared equals 990.4 meters squared per second squared. and then get the square root. So we need to select the positive value. Square root of this amount is equal to 31.5 meters per second, the initial velocity of the ball. Okay, now how about the maximum height reached by the ball? So we have this diagram again. We have from 0 to point 2 and then to point 2, where point 2 represents the maximum height reached by the ball. And at this point, the velocity v sub 2 is equal to 0. So in this case, we are asked to find the value of y from point O to point 2. To find this height, we need to know this distance y12 and then add it by this amount y01 so that you can find y. So how do we calculate y12? We need to consider point 1 and point 2. So what formula must be used to find y12? We have v2 squared, the final velocity, equals v1 squared, the initial velocity, minus 2g y12. V2 is 0, we have 0 squared equals 18 squared, and it's twice of 9.8 times y12. We have transpose this one to the left side, so the product of 2 and 9.8 is 19.6 times the unknown equals 18 squared is 324 meters squared per second squared. So that y12 is equal to 16.5 meters. So divide this amount, 324 over 19.6 gives us this result. Now, therefore, we can find the height y, which is equal to the sum y01 plus y12. So 34.0 meters plus 16.5, the result is 50.5 meters. This is the maximum height reached by the ball from point O to point 2. Number 3. A stone is thrown straight up and goes back to the starting point in 28.0 seconds. Question. In A, what is the initial velocity of the stone? Next is, how high does the stone go? Okay, let's look at what are given. So we are given total time. So the time for the stone to move from the starting point and then back to that same starting point. So that the time for that stone to travel from the starting point to the highest point is going to be one half of this, which is 14.0 seconds. Now, how do we calculate the initial velocity of the stone? Since we are given this time, and at the highest point we know that the velocity is equal to 0, we can use the formula v at the highest point equals v initial minus g times time. Okay, so we can now solve for v initial. We have v initial equals v plus g times time t. But v is equal to 0. 0 plus 9.8 meter per second squared times 14 seconds. The product of these two, 9.8 and 14.0, is 137.2 meters per second, the initial velocity of the stone. So next is to calculate the distance traveled by the stone, the maximum height reached by the stone. Okay, what equation must be used? We have y equals v initial times time minus 1 half gt squared. Then we have an initial velocity of 137.2 meters per second times time of 14 seconds minus 1 half of 9.8 times 14.0 seconds and then squared. So the product of 137.2 and 14 is 1,920.8 meters. And the product of 1 half, 9.8 and 14 squared is 960.4 meters. And then subtract. Then the value of y is 960.4 meters, the maximum height reached by the stone. Number 4. A boy throws a ball vertically downward with an initial velocity of magnitude 15.0 meters per second from the roof of a building. The ball passes the top and bottom of the window below for 0.10 seconds. If the window is 2.0 meters high, what is the distance from the roof of a building to the top of the window? What is the velocity of the ball as it passes the bottom of the window? Okay, let us write what are known. this problem. So first we have an initial velocity of negative 15.0 meters per second. It is going down. Then we have a time from point 1 to point 2. Point 1 here represents the top of the window. Then point 2 represents the bottom of the window. So it takes 0.10 seconds to travel from point 1 to point 2, or from top to bottom of the window. Then we have a displacement h12 to be equal to negative 2.0 meters, and the actual height, or the height of the window, is 2.0 meters. Okay, here is the diagram. We have the ball that is moving from the origin to point 1 and then to point 2. So point 1 is the top of the window, point 2 is the bottom. Then this distance here is given. This is 2 meters in magnitude, and then the time from point 1 to point 2 is 0.10 seconds. So point O as an initial velocity at point O of negative 15.0 meter per second. And then this height is unknown. Okay, this one represents, or h represents, the distance from the roof of a building, point O, to the top of the window, point 1. How do we solve the value of h? To find h, we need to find, or to calculate, v1 first at point 1. Okay, because the only given here, if you're going to consider point 1, point 1, the only given is the initial velocity, and of course the acceleration, which is negative 9.8 meter per second. But we need to find v1 first before finding h, by considering point 1 and point 2. Okay, so we have now the formula. We have the displacement h12 is equal to the initial velocity at point 1, v1, times time 12 minus 1 half g t12 squared. So h12 is negative. That's the value of h12. Displacement, we have negative 2.00 meters equals v1 times 0.10 seconds, the time, minus 1 half, or 0.5, times 9.8 times 0.1 squared. So we have now negative 2. So the product of the three of them, 0.5, 9.8, and 0.1 squared, is 0.159. We are going to put this here on the left side. We have negative 2 plus 0.159 gives us negative 1.951 in meters. Then divide it by 0.1. Okay, it gives us v1 of negative 19.51 meters per second. So we have now this result. Okay, so v1 is negative 19.51 meters per second. Then going back into this diagram, we can now find h by considering point O and point 1. So to solve for h, we need to consider point 1 and point 1, and then we need the formula v1. This is going to be the final velocity at point 1, considering point O as the initial velocity. Initial point, this is final point. We have v1 squared equals vu squared minus 2g times h. Okay, so v1 is negative 19.51 squared equals v initial is negative 15, and then squared minus twice of 9.8 times the unknown h. 19.51 squared is equal to 380.64 meters squared per second squared, while negative 15 squared is 225 meters squared per second squared. Then the product of 2 and 9.8 is 19.6 meter per second squared, then times h. Okay, so h is the unknown. And then if you're going to put this on the left side so that it becomes positive, and then put this number here, 380, on the right side. So we have now negative 380 plus 225 gives us negative 155.64 in meters. Then over this amount, 19.6, gives us h equal to 7.94 meters. This is now the height, or this distance, because we are asked to find the magnitude, only the distance, so we have to remove the negative sign. So next is to find the velocity of the ball as it passes the bottom of the window at point 2, here. So we can consider again point 1 and point 2. So V2 equals V1 minus G times T. Okay, so V2 is negative 19.51, okay, for V1, then minus 9.8 times point 1 seconds. We have the product of these two, and then plus this, but it's negative. So the result is negative 20.5 meters per second. The velocity of the ball as it passes point 2 at the bottom of the window. Number 5. Two objects, A and B, start at the same time. Object A is thrown straight down with a speed of 12.0 meters per second, while object B is released from rest. Object B is ahead by a certain distance, y, from object A initially. Object A overtakes object B after object B has traveled 250.0 meters from the starting point. What is the value of y? Okay, so what are the given numbers? We have the initial velocity of A is negative 12.0 meters per second, while that of B is 0 because it starts from rest. And then the height, YB, the displacement is negative 250.0 meters. It's meaning it's below the reference point, but the distance traveled is 250.0 meters. Here is the diagram of the two objects, A and B. So A has an initial velocity of negative 12 meters per second, and B has an initial velocity of 0. So it starts from rest. So this is the path followed by A. It's moving down. So B is initially ahead by a distance of y meters. So this height is equal to y. So from point A to point B. And this is going to be the unknown. Okay? Note that when B travels a distance of 250 meters, A is able to overtake B. So note that the time for object B to travel this distance, which is 250 meters, equals the time for A to travel this distance, which is equal to YA. Now to find Y, we can look at the diagram here, and then we can then say that YA is equal to Y plus YB. Okay, but since they are moving at the same time, we can first find the time by considering object B, because this is given, the initial speed is given, and then height is given. Okay, what formula must be used to find the time? So after finding the time, we can now solve for YA, then solve for Y. So what formula must be used to find the time? So we have now considered object B. So we have YB equals the initial of B times time minus 1/2 GT squared. Then YB is negative 250 equals 0 times T minus 1/2 times 9.8 times T squared. And then 1/2 of 9.8 is 4.9. Okay, so we can remove the negative sign. We have 4.9 T squared equals 250 meters. And then divide, we have T squared equals 51.02 seconds squared. So 250 over 4.9 is 51.02. Then the square root of that is 7.14 seconds. This is now the time for B to move from here to here, and for A to move from this point up to this point. Okay, now we can use this time to solve for YA. Okay, so consider object A. We have now YA, same formula as this. We have V initial of A times time T minus 1/2 GT squared. So you have YA equals negative 12. This is negative 12 times 7.14, the time, minus 1/2 of 9.8 is 4.9, then times T squared, we have 7.14 seconds squared. And then we have now this product here, 12 and 7.14 is negative 85.7. And the product of these two, we have 7.14 squared and 4.9 is 250. Okay, and then combined, we have now negative 135.7 meters. So it's negative because the The direction of motion is downward and it's below the reference point at point A. Okay, from YA, we can now determine the value of Y. So we can use or solve this problem in terms of their magnitudes, the distances. So YA equals Y plus YB. Solving for Y, we have YA minus YB, and note that YA is 335.7 meters in magnitude and minus 250 meters for YB. So that the value of Y, the distance from A to B, initially is 85.7 meters.